One of the things that we're trying to do here in the Green Building Research Lab is to provide a service for local industry. So in addition to being a resource for our university partners across the Oregon University system, we make this laboratory and its facilities available to industry partners. One of the goals is to bring in fresh ideas from industry of technologies to test or evaluate systems that we can start to explore the characteristics of to better the green building industry down the road. And so toward that end, we welcome industry to come and visit with us and see what we can do for them. We also have the capability to loan out equipment, monitoring equipment such as infrared cameras and temperature humidity sensors, CO2 sensors, that sort of thing. We're really looking for more partners right now, trying to bring together as many industry partners as we can and make as big of an impact as we can. We certainly do encourage more collaborators to come forward and try to partner with us. So the fundamental purpose for the Green Building Research Laboratory is to serve as a focal point for green building related research and education activities in the region. We have four fundamental goals that we try to accomplish here. One is fundamental research, one is applied research, one is to act as an industry resource, and then finally to be an educational opportunity for our students and local industry as well. The instrumentation that we have in the lab ranges from equipment that can be used to assess the thermal and spectral properties of materials such as glazing materials or building envelope coatings and so forth. So we can measure with our spectrometer, we can measure spectral reflectivity, the effect of albedo of surfaces, the transmissivity and solar heat gain coefficients of glazings, that sort of thing. We have a lot of instrumentation for indoor environmental quality monitoring and data logging. So we have these portable data loggers that we can deploy in an existing building to assess thermal performance of that building and what its occupants are exposed to. We have a low-speed wind tunnel that's a very effective device for evaluating flow past urban structures, individual buildings, flow within buildings, flow between buildings. We are currently in the process of building a much larger wind tunnel that will be part of the mechanical engineering department here at Portland State, but we'll partner with them to allow us to measure the flow interactions with larger arrays of buildings. So toward that end, we have flow visualization capabilities, of course, smoke pens, but also neutrally buoyant helium bubbles that we can flow past a building structure to look at recirculation, dispersion, and separation, say, across the top of a building. We also have a lot of equipment and interest in trying to understand how buildings interact with the outdoor environment, so relations between buildings and the urban climate. So we have capabilities for measuring urban heat fluxes of both sensible and latent heat flux, as well as carbon dioxide flux from urban settings. We also have a lot of modeling capabilities. We have a fairly high-end computational platform, as well as a number of workstations that we can use for everything from building energy simulations or whole building energy simulation tools to computational fluid dynamics modeling of both internal flows within buildings, natural ventilation, but also external flows outside of buildings, between buildings. We also have more larger scale atmospheric modeling capabilities that can allow us to bridge the scales from the individual building to the neighborhood to the city.